So we're finishing up friction, but we're not going to talk about air resistance. There's some things that is probably useful for you to know about air resistance, right? Because it really does play a huge part in many parts of physics, in particular, right? Well, in particular, obviously, somebody who's jumping out of an airplane couldn't jump out safely without air resistance because you depend on that to fill your parachute and to slow you down. Right? So somebody jumping out of an airplane is going to fall and they're going to speed up. And whether their parachute opens or not, they're going to reach terminal velocity. Terminal velocity doesn't mean terminal like you're dead. Terminal velocity means that you've reached the fastest velocity you're going to go. And actually, a parachutist, even before they open their parachute, hits terminal velocity pretty quick. Can't remember how long it takes, but it doesn't take very long at all to get to terminal velocity. I don't know, a couple seconds, 30 seconds, a minute, I don't know. But anyway, so what is terminal velocity? Terminal velocity means that you don't speed up anymore. What does that mean? That means that your acceleration is zero. You don't speed up anymore. V is constant. That's what terminal velocity means. And terminal velocity. And so that means that a free body diagram of you as you're falling, and by the way, the brown square was supposed to be your parachute. I didn't take away your parachute. I'm just drawing a free body diagram, so I'm not going to draw the parachute in. You still got your parachute, so you're not going to die. So let's go ahead and draw a free body diagram of the parachutist, whether they have their parachute open or not. There's going to be a gravitational force down, and they're not speeding up, so there must be a balancing force up, and that's going to be air resistance. Right? That's going to be air resistance. Those are the only two forces on you as you fall, and those two, when you reach terminal velocity, must be equal. Just a couple of quick facts about air resistance. One of the other things is that the air resistance force of air resistance goes like, whoops, that's supposed to be force of air, goes like your velocity. It increases with velocity at low speeds, and your air resistance goes as velocity squared at high speeds. That's good to know. It comes up sometimes, but it won't come up much in intro physics, if at all. Whoops, at high speeds. So in other words, the air resistance, as you speed up, gets larger quicker, right? Because it originally gets larger as velocity, but then it gets larger as velocity squared. So it gets larger quicker the faster you go. Hence, you hit terminal velocity pretty quick. Now, the air resistance is dependent on the area that is against the air. So if you want to reach terminal velocity fast, I'm doing the motion, you can't see me. You spread eagle, you spread out your arms and legs. If you want to speed up more, you bring in your arms and legs. You have less surface area for the wind to hit, and you can go faster. Okay, that's all we're going to do with air resistance. We're not going to do any of the equations with air resistance, and we'll move on from there to uniform circular motion.